Okay, so this is section 4.4. So one of the purposes of Math 92 is to, when possible, to go over some kind of foundational mathematics. And this is exactly one situation where we can do this, where it fits well with our trig class. So what we want to do, if you look at 4.4, the idea is we want to solve problems that look something like this. Sine squared of x minus 5 sine of x plus, sorry, let me do one that's more realistic. Something like 2 sine squared x minus sine x minus 1 equals 0. All right, so find all solutions to this problem. Okay, so this is kind of a continuation of that section we did a while back, where we wanted to solve things like, remember, we had problems where we had to solve sine of x equals 1/2, find all solutions, right? Or maybe sine of 3x plus 1 is equal to root 3 over 2, something like that, right? Find all solutions. Or maybe all solutions within an interval or something like that, right? So this is a continuation of that, but you can see things have gotten a little more complicated in that our equation here, right, has a sine squared in it, and that makes it a lot more unpleasant, potentially, compared to something like this or something like that. All right, so what we're going to do is we're going to deal with problems of this kind. And in essence, they're actually fairly easy once we kind of know what to do and once we break it down into smaller problems. All right. So the idea is this. I want to solve, let's just work with this problem here. I want to solve 2 sine squared x minus sine x minus 1 equals 0, right? I notice a sine squared x, sine x. So I convert this problem to a new one by, let's say, making a new variable name. Let's let y equals sine x. Okay, so this is very, very similar to the idea of this problem up here. Remember, the way we did this problem was we made a new variable name for 3x plus 1, right? So we called that y equals 3x plus 1. And what that meant was we only had to solve sine y is equal to root 3 over 2, right? Which is an easier problem. And then at the end, we need to convert the y's back to the x's using y equals 3x plus 1, right? So here we're going to do exactly the same idea, except we're going to do our substitution, kind of this y, in a slightly different context, right? We're going to let y be sine x. And so now our problem becomes 2 sine squared x minus sine x minus 1 equals 0 becomes 2y squared minus y minus 1 equals 0. Okay, so what we're going to do is we're going to solve this guy here, and this is a quadratic equation. So the way we solve this is, at least in this section, the way we're going to solve these is by factoring. All right. Except for a couple really basic examples, we'll do it in a couple minutes. But a problem like this that's more complex, we're going to do them by factoring. All right. So we're going to figure out how to factor this. And that's what the core of this Math 92 video is going to be about. All right. So we're going to figure out how to factor this, and it's going to turn out to be 2y y minus 1 plus 1 equals 0. Okay. And one thing to remember, when you factor, you can always check your answer, right? Did I factor this correctly? Well, 2y times y, it gives me a 2y squared. 2y times minus 1 gives me a negative 2y. 1 times y gives me a plus y, so minus 2y from the previous one, plus y gives me minus y, so I have this term right here in the middle. And then 1 times minus 1 gives me negative 1, which gives me that term. So it looks okay. All right. Okay. So I have this factored, and whenever you factor, so the reason why we factor is because whenever you have two things multiplied to 0, that means one or the other has to be 0, right? And so that means we can split this into two problems. 2y plus 1 equals 0, y minus 1 equals 0. Okay, you cannot do this if the right-hand side is not 0, right? Because again, 0 has this special property that if two guys multiply to 0, one of them has to be 0, right? If that 0 were let's say 2, right? There's many, many ways for two things to multiply to 2, right? So it's not going to work. Okay, so on the left side, we get y is equal to minus 1/2. On the right side, we get y equals 1. All right. What do we do with that? Well, we wanted x, right? We wanted to find x so that blah, 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 blah. So we need to rephrase this in terms of x now. So y equals minus 1/2 on the left side becomes, well, what was y? Y was sine x, right? So sine x equals minus 1/2. And on the right side of the board, we have sine of x. I forgot to write the x there. Sine of x is equal to 1. Okay. All right, what do we do now? Well, this is exactly a problem from 4.2 or I believe it was 4.3. All right. 4.2/4.3. Okay. So here, for example, we look at the graph of sine. We know sine of 30 degrees. Let me not use degrees. Sine of pi over 6 is positive 1/2, right? So in order to get another solution, we notice that this one here is pi over, it's pi, right? So if we move pi over 6 from pi, so in other words, pi plus pi over 6, I'm going to get minus 1/2. And also, if I move pi over 6 to the left from 2 pi here, I'm going to get another solution, 2 pi minus pi over 6, right? So this one is going to be 7 pi over 6. This one is going to be 11 pi over 6, right? So my two intermediate solutions are going to be these two guys. And so that means x is equal to 7 pi over 6 plus 2 pi k, comma, x is equal to 11 pi over 6 plus 2 pi k. Okay. So all of these numbers, so this is k equals 0, 1, 2, and also the negatives. Let me write it like this. K equals integer. That's the way we used our notation in that section, right? So in other words, k could be 0, 1, 2, minus 1, minus 2, and so on. Okay, so we actually have, again, an infinite number of solutions, and these represent two sets of those solutions. And all of these are the ones that give you sine of x equals minus 1/2. All right. And we always have to look on the other side of the board and see if there's any solutions to that. Sine of x equals 1. Well, again, picture for sine looks like this. There's only one solution, right? X, or one core solution between 0 and 2 pi. And that's going to be x equals pi over 2. There's no secondary solution like on the other side of the board, because there's only one hump right here, or one top of the hump. And so every 2 pi, we're going to get other solutions. So x equals pi over 2 plus 2 pi k. Okay, so all together, so again, k equals integers. All together, we're going to have three sets of solutions. This set right here, this set right there, this set right there, and that set right there. Okay. All right, so there's nothing new in this latter part of the problem. Below this line, you already know how to do these problems. The only kind of painful thing is you actually have to do two problems, right, instead of one, because you actually have to solve both sides of the board. And again, here, if I asked you to only find the solutions in the interval 3 pi to 7 pi, right, you could do that. Again, using the techniques from 4.2, 4.3. So the core of this problem here, or the new feature of this problem, was going from doing this, let y equal sine x, and then having to do this factoring right there. All right. So what I'm going to do, what I'm going to focus on here, in this video is factoring, right? Because if you know how to factor, then you can solve all the kinds of problems that look like that. All right, where again, you have a trig function, it's quadratic, right? And of course, it's only the same trig, sine, right? If there were mixed sines and cosines, things would be a little more complicated. We're not going to bother with that for our class. Okay, so the question is, how do you factor, right? How did I figure out that this 2y squared minus y minus 1 equals 0 was 2y plus 1 times y minus 1, right, equals 0? So let's start with kind of the most simple types of problems involving quadratics. And those are the ones that look like x squared equals a number, right? X squared equals 9, right? So first of all, how do you solve this? If you have x squared equals 9 just like this, you just take the square root of both sides. So x equals square root of 9. And then again, whenever you take the square root of both sides of an equation, you got to pop out a plus or minus, right? Because whatever answer you find, negative of that will also work. Because when you square the negative of that, the minus sign goes away. All right. So this is plus or minus 3. So there's two answers to x squared equals 9. 3 squared equals 9, minus 3 squared also equals 9. Okay, so that's the kind of the most basic type of problem. And again, in terms of our class, you might see a problem like sine squared x equals 1/4, right? Solve this. So that would mean y equals sine x, y squared equals 1/4, right? If you let y equal sine x, then our problem becomes y squared equals 1/4, which means y is equal to plus or minus square root of 1/4, which is 1/2, which means we need to solve sine x equals plus or minus 1/2, which means we need to split the board into sine x equals 1/2 and sine x equals negative 1/2, and you do each of those individually. And you put together all the solutions, all right? Okay, so that's the most basic quadratic. The second most basic quadratic type of problem is where you have x squared plus something x, right, is equal to 0, for example. Okay, so any kind of quadratic problem where you actually have x squares and x's, the way to solve those is always to throw everything to one side and have a 0 on the other side. All right, because the way to solve these is always to exploit the fact that the product of two things equals 0 means one of those two has to be 0. At least when we want to work with factoring, which is what we do in this class. All right. So once we do that, we see that once everything is on one side, if they didn't start out on one side, we see that we have x squared here and we have x here, so we can pull out an x. So this is equivalent to x times x squared plus, sorry, x times x plus 3 equals 0. Okay, so that means we split the problem. X equals 0, x plus 3 equals 0. The one on the left is already done. The one on the right tells me x equals minus 3. All right, so I have two solutions like that. Okay, so maybe a problem in terms of sines and cosines. Maybe I have cos squared x plus, here's an interesting one. Let's do 3x, 3 cos x equals 0, right? So then you would do y equals cos x, right? Let y equals cos x. Then this problem becomes y squared plus 3y equals 0, which becomes y plus, sorry, just like above, right? Y times y plus 3 equals 0, which means y equals 0, y equals minus 3. Y is cosine, so this is cosine x equals 0 on the left. Cosine x equals minus 3 on the right. All right, cosine x equals 0. When is that? Well, again, you do what we did in sections 4.2 and 4.3. There's going to be two solutions, and every 2 pi, right, you propagate those every 2 pi. Okay, so there's going to be a lot of solutions here. But notice on this side of the board, cosine x equals minus 3, no solutions. Because cosine x can never be a number less than negative 1. All right, because cosine always lives between plus 1 and minus 1. So notice that something like this can happen. So this side of the board gives me no solutions, and my only solutions are from that side. Okay, by the way, when you're solving these problems, if you have something like cosine squared x equals, let's say 1/4 cosine x, still throw everything to one side. So this is cosine squared x minus 1/4 cosine x equals 0. And then you do it just like what we said. All right. Don't do this. So don't say, so this one is okay. But if I do this, and I cancel the cosine, I see a cosine x here, I see a cosine squared x here, so it's very tempting to cancel the cosine x's, and then I would have cosine x equals 1/4, right? But notice if I do this, I'm only going to get half the solutions that I actually should get. Because if I did this the correct way up here, right, what would happen is I would end up with cosine x equals 1/4, and on the other side would be cosine x equals 0, right? Just like up here. Okay, so the problem here is that when you cancel on both sides, right, what are you actually doing when you cancel on both sides? Technically, what you're doing mathematically is you're dividing by cosine x on both sides, right? But you're not allowed to divide by cosine x on both sides if cosine x were equal to 0, because you would be dividing by 0. Okay, so when you do this canceling on both sides, you're secretly, possibly dividing by 0. And so that's why this is a very, very dangerous thing to do, especially when you're trying to solve equations. All right. Of course, you can certainly do canceling on both sides if it's just a constant, right? 3 cosine x equals 6. Certainly, I can cancel this 3 and cancel that 6 and make it into a 2. That's no problem. Because what I'm doing there is I'm just dividing by 3 on both sides. And there's no problem dividing by 3 no matter what, right? 3 is just 3 is a number, and you can certainly divide by 3. The problem over here, again, is that you're dividing by cosine x, and cosine x can sometimes be 0. And if it were 0, you just did something very illegal. All right? So be very, very careful here when you see these kinds of problems. Okay, so those are the two kind of more basic quadratic type of problems, right? So this tells me x equals 0, x equals -3. What about the more interesting, kind of the more difficult ones, where you have something like x squared minus 5x plus 6 equals 0, right? How do you actually deal with these? X squared minus 5x plus 6 equals 0. So the thing is, for this section, we're focused on factoring, how to factor. All right. So sometimes these things can be factored and then they become easy to work with. How do you figure out how to factor? Well, the way I like to think of it is we're going to break this down into the product of two things, right? X, a number here, and a number here. I'm using a box there, so let me use a triangle for this one here. All right, so our goal is essentially to figure out what this number is and what that number should be, right? So how do we do that? Well, these two guys, this x squared minus 5x plus 6 has to match with this thing down here, right? And so what that means is if I FOIL this guy down here out, if I FOIL it out, every term has to match. Right? So let me actually put a plus here and let me put a plus there, okay? So when I FOIL this guy down here out, what am I going to get? I'm going to get x squared plus x times triangle, so triangle x, plus box times triangle, plus box times, box times x, and then box times triangle. Okay? All right, so the whole point of factoring is that this guy here has to be the same as that guy there, which means that this guy up here has to be the same as this guy down here, all right? Which means this 6 has to be the same as this product, okay? And this minus 5 has to be the same as, let me simplify this guy here. This guy here is triangle plus box, all times x, right? So that minus 5 has to be the same as this guy in here. Okay? So what happens is we're going to make guesses for what triangle and box should be, using the fact that their product has to be 6. All right, we're gonna base our guesses on that, on this last part here, on the triangle times the box, because there's only a few possibilities for two. So we're only doing whole numbers, right? Triangle and box are only going to be whole numbers. So when we factor, we only want whole numbers for triangle and box. So there's only a few possibilities to make 6 out of a product, right? On the other hand, right, our other option was to try to make -5 out of the sum, right? There's an infinite way to make -5 out of a sum, right? -5 is equal to -3 minus 2. It's also equal to -7 plus 2. It's also equal to 3 minus 8, right? It's also equal to 0 minus 5. So there's an infinite number of ways. If we base our guesses on this middle part, triangle plus box, there's an infinite number of possibilities. But if we base our guesses on the product, there's only a finite number of ways to get 6 out of two things, right? There's 3 times 2, right? There's 2 times 3, which is essentially the same thing. There's 1 times 6, and there's 6 times 1, which are essentially the same thing. So in essence, there's actually only 2 possibilities, right? So when we base our guesses on the product, it makes it very manageable to figure out which guess is the appropriate one, all right? Okay, so how do we figure out which guess is appropriate? Well, the product has to be 6, so it's got to be either 3 and 2 or 6 and 1, right? However, we know that or negative versions of these, right? Because -3 times -2 is also 6. -1 times -6 is also 6, right? So again, we're basing it on 3 and 2. We're basing it on 3 and 2 or 1 and 6. But of course, the signs of these guys might vary. So it might be plus or minus 3, plus or minus 2. Let me kind of indicate it like that. Okay, so the question now is whether we should use plus or minus, and whether we use 3, 2, or 1, 6. All right. So if we think about this, first of all, we need the product of our two numbers to be positive 6. So if we choose 3, positive 3, then we have to choose positive 2, right? Because 3 times minus 2 would be -6. We don't want -6. We want positive 6. In the same way, if we choose -3, then we have to choose -2 in order to get positive 6 as their product. All right? And with the 1 and 6, same idea, right? 1, if I choose positive 1 and I choose positive 6, then I have to choose positive 6. If I choose -1, then I have to choose -6. So again, our possibilities are very limited, right? Okay, now, how do I figure out which one of these 4 it should be? Well, the sum of my two guys has to be -5, right? So now I just think about which ones can be -5. 3 plus 2 is not -5. -3 minus 2, -5, right? So that's going to be the one I want. And of course, the other two are not going to work. This one is 7. This one is -7. So that means this guy factors into x plus -3. So I'm just going to write it as x minus 3. And x plus -2. So I'm going to write it as x minus 2. Okay. So what we've concluded is that this guy here is equal to that guy there. All right. And again, we can always check our answer by foiling it back out, right? X times x, x squared. X times -2 is -2x. X times -3 is -3x. -3 times -2 is +6. And altogether we get x squared -5x plus 6, which is exactly what we wanted. All right. So that's the general idea behind this technique of factoring. Let me do a couple more similar examples. And then we'll talk about more complicated situations. So x squared plus 6x plus 8. All right. And I'm not even going to write the equal 0, because essentially all I care about in this mini section is how to factor it. All right. I'm not worried about solving anything at this point. So just how to factor this. So how do I factor this? Again, I need two numbers that multiply to 8. So, could be 8 and 1. 8 times 1 is 8, right? 2 times 4 is also 8, right? Are there any others? 3, you can't get 8 out of 3, right? So that's it, okay? Let's see. We have a plus 8. So the product of them have to be plus 8. So that means I either use 8 and 1 or negative 8 and negative 1. Or I use 2 and 4 and negative 2 and negative 4, right? I can't have mixed signs. I can't have 2 and minus 4 because their product would be negative 8. Okay, so the signs have to be the same, all right? Let me explicitly write that out. So plus 8 plus 1 plus 2 plus 4, or the other option was minus 8 minus 1 minus 2 minus 4. All right, let me change the colors there. So these are my 4 possibilities at this point. And if you want, you can even just write them all out and check them, right? But hopefully the goal would be to do as many problems as these as possible to get used to them, and then where you could almost do them in your head. Okay, so which one of these 4 do we want? Well, we need the sum of the two numbers that we picked. They should be 6, all right? So, well, 8 plus 1 is definitely not 6, so we toss that one. Minus 8 minus 1, not 6. Minus 2 minus 4, oops, that should have been plus 2 plus 4. Minus 2 minus 4 definitely doesn't work. Plus 2 plus 4, that one works. All right, so that means x squared plus 6x plus 8 should be x plus 2, x plus 4. Okay, and again, you can check your answer. Notice that we don't actually have to, for example, for these minus 1, minus 8, we don't even have to actually add them, because I know that minus 8 minus 1 is going to be negative, and that's not even close to positive 6. So I don't actually have to do a lot of the computations, right? And here, this plus 8 plus 1, I don't actually have to add them, because I know 8 is already bigger than 6. So already I know, because it's an 8 and then a plus 8 and a plus 1, I'm only going to get bigger. So there's no way I can get to 6. So it's got to be this guy here. Okay, so there's a lot of mini analyses you can do to rule these guys out. But at worst, you just try all the possibilities. All right. Okay, let's do another one. X squared minus 2x minus 8 equals 0. Oh, sorry. Again, I don't even care about the equal 0. I'm just focused on factoring. All right. So here again, I need the product of my two things to be 8, right? So that means 8 and 1, 4 and 2, right? And then, either plus or minuses for them. Let's see. I need a minus 8, right? So the only way to get that out of the product of two things is one has to be positive, one has to be negative. So it's got to be something like plus 8 and negative 1, or negative 8 and plus 1, or plus 4 and negative 2, or minus 4 and positive 2, right? So again, let me write them all out. Here we got minus 8 plus 1, and then minus 4 plus 2, right? So these are my 4 possibilities. Okay, and again, they have to be opposite signs, because I have a minus 8 here. Okay, and then, well, I need the sum of these guys to be negative 2, right? So immediately, plus 8 minus 1, not even close to negative 2, right? Minus 8 plus 1, not even close to negative 2, right? 4 minus 2 is positive, so that's no good. So it's got to be minus 4 plus 2, all right? And that does work. Minus 4 plus 2 is negative 2, all right? So this guy is x minus 4, x plus 2. Okay, so I really like this kind of way of reasoning the problem out, as opposed to, I think probably a lot of you have seen other methods, like where you do this x thing and you put numbers here and you try to work them out. I always like to stay as close as possible to the math, to actually what I'm doing, which is kind of matching the box and the triangles, right? I want to stay as close to that as possible, just so I don't kind of lose uh, lose kind of connection to what I'm doing mathematically, right? Where I feel like sometimes when you do stuff like this, you kind of at some point stop understanding what you're actually doing and just manipulating objects. All right. X squared minus 6x plus 9, right? So here, two things have to multiply to 9. So 9, 1, 3, 3, right? They both have to have the same sign because I need them to the product to be positive, right? So minus 9, minus 1, minus 3, minus 3. And I need their sum to be negative 6. So it's got to be minus 3, minus 3. All right, so this guy is actually x minus 3 times x minus 3, which is x minus 3 whole thing squared. All right. Okay, notice something interesting, actually. We could do this one as well, right? It's perfectly legal to do this problem, to factor this, right, in the same way, right? Because we can think of this as plus 0. So how do you get two things multiplied to 0? Well, one of them has to be 0, right? And the other one, actually, I can't say what it is because anything multiplied to 0 is 0. But then I need the sum of these two guys to add to 3. So that automatically tells me this guy should be 3. All right. So I can even do this kind of idea for something that's in a way kind of degenerate, right? It doesn't look like it has another term. In the same way, I can do this as well. X squared minus 9, right? I can factor this. This would be the same as x squared plus 0x minus 9, right? And so what I need is two things to multiply together to be negative 9. So 9, 1, 3, 3. I need a negative 9, so minus 9, positive 1, 9, negative 1, 3, let's say minus 3, 3, and 3, minus 3, which is, of course, actually the same. They need to add up to 0, so it's certainly not going to be, let me circle the possibilities. These two are the same. So they have to add up to 0, so not this, so it has to be this one. All right. And so that tells me this should be x minus 3, x plus 3. Okay. So this is a very flexible method for solving these problems. You could use it on these quadratics that even don't look quite, in a way, look quite right, or look quite typical of the other ones you see. Okay, so let's get to more complicated situations. Oh, sorry. Actually, let me do one that's a little more complicated than the ones we've seen. So let's say x squared minus, let's say plus 2x minus 24, right? Because all the ones I've done so far, there's only a very few possibilities. I want to do one that's at least there's a few more possibilities. So because 24 here can be broken down in many ways, right? 24 and 1, 12 and 2, 8 and 3, 6 and 4, nothing more than that, right? Oops. So, we have a lot more possibilities, but still, how do we do these? It's still the same way, right? We reason out which one of these are reasonable and which ones don't work. So again, we have a minus 24. So one of these, for each of these pairs of numbers, one of them has to be positive, one has to be negative. All right. However, the sum of these two numbers has to be 2, right? So we can immediately see that no matter what, the 24 and 1 are not going to work. Because whether the 24 is negative or the 1 is negative, when you add them together, you're going to get something way, way bigger than 2, right? Or way more negative than 2, right? Same with the 12 and 2, right? If the 12 were negative and the 2 were positive, right, their sum would be really big because 12 and 2 have a big distance between them, right? And same if the 12 were positive and 2 were negative, big distance between them. So in a way, I can immediately rule these two guys out. All right. And same with 8 and 3, right? The distance between 8 and 3 is 5. So there's no way, no matter which one I give the negative to, there's no way I'm going to get 2. All right. So that means it's got to be 6 and 4. Okay. Which one should I give the negative to? Well, one of them has to have a negative sign, but they have to add up to positive 2. So that means the negative sign has to go with the smaller number, has to go with the 4, right? So that 6 minus 4 gives me a positive 2. Okay. So if you reason it out like that, you never really even have to consider the minus 6, 4 possibility, because you know that, again, you need a positive 2, so the sum has to be positive, right? So the negative sign cannot be with the negative 6. It has to be with the negative 4. And so we have x squared plus 6, sorry, x plus 6, x minus 4. Sorry, x minus 6, x plus 4. X plus 6, x minus 4 as my factor. Okay, finally, the problems that you'll see mostly in this section, the sines and cosines, are going to be ones which look something like this. So you need to solve something like this, where there's actually a coefficient there, right? So all the ones we've done, it's the x squared is kind of by itself. There's no number in front of it. There's no coefficient. But in terms of sines and cosines, the ones that you're going to be able to solve are typically going to have a number in front, all right? Because you're not going to be able to solve, for example, if this were sine and cosines, right? You can't solve sine of x equals 6 equals negative 6, right? So these are going to be the ones that you see. How do you deal with this? Well, the idea is exactly the same. You need to factor, right? But now instead of just a box here and a triangle here, right, you're going to have the possibility of having something here, a number here, circle, and another number here, happy face. All right. So what happens here is that these two products, the circle and the happy face, have to multiply together to be that 2 right there. All right. So that gives us an additional kind of complication. The other part on the other side, let me actually do this in red. So on the other side, here, these two still multiply together to be the minus 1, right? And again, you see this just by foiling this out, right? So let me again put a plus here and a plus there. If I FOIL this out, I'm going to get circle happy face x on one end. On the other end, I'm going to get box triangle, sorry, x squared, right? And in the middle, I'm going to get cross terms, right? So circle triangle x, and then I'm also going to have a box happy face x. So it's going to be like that. So you can see things are a little more complicated, but again, your guesses are going to be roughly done the same. These two guys have to multiply to -1, and these two guys have to multiply to 2, right? So you make your guesses for each of these, and then you see which ones of these guesses fit with this negative x, with the -1 in front of the x. Okay? So luckily enough for this one, right, there's only a couple possibilities. Box and triangle, how do you get 1? Well, 1 times 1 is 1. We need a -1, so 1 has to be positive, 1 has to be negative. So the only possibility is 1 and -1. All right? So we already know for this problem that one of these has to be 1, the other has to be -1. Okay, for the 2, there's only one way to get 2 is 2 times 1, right? So 2 and 1. All right. And the way we're going to do these problems is we don't have to worry about -2 and -1, even those multiply to 2, because the difference between that and 2, 1 is that these guys will have opposite signs. So in a way, if you can always consider only positives here, and then the negatives possibilities here will take care of it, right? So what I mean is that this could be 1 and -1 or -1 and 1, all right? Okay, so, and that will cover the -2, -1 case. All right, so now we just need to figure out the cross terms, right? And we just, essentially, we just guess, right? So we say, okay, I want to give the 2 as the circle, and I have an x here. That means the 1 has to go here, right? And then now I just know that one of these numbers has to be 1. The other of them has to be -1. Okay, so which one is 1? Which one is -1? Well, I just think about the cross terms. This one times that one is going to give me 2, right? Either plus or -2, depending on whether this is a +1 or a -1, right? But ultimately, I need a negative x here, right? So if I put a -1 here, right, that has to be a +1 here, right? Well, that would give me a -2 and then +1. -2 plus 1 is -1. Okay, so that's why I know that I should give the minus sign to this guy, right? Because I know that the 2 is going to hit the -1. And so ultimately, I'm going to get a negative sign there, which is what I need. Okay, and again, I can FOIL this out to make sure I'm okay. 2x times x is 2x squared. 2x times -1 is -2x. 1 times x is just x. And then 1 times -1 is -1. And so you can see the -2x and the x become just -x, which is what we're looking for. All right. Had we done it the other way, with a -1 here and a +1 there, then we would have ended up with a +2x here and a -x there, and we would end up with a positive x as the middle term, which is not what we're looking for. All right. So again, I think this is a really nice way of doing these problems. All right, and so if you're not used to these, it might be a little tedious thinking about all the possibilities, but the good news is that you can actually just try all the possibilities, and if you do try all the possibilities, and it is factorable, which all the problems in this section are factorable, then you're all set. Then you can actually find the solution. So let's do another one. Let's factor this. So that's a 3, so that means 3 and 1, right? There's only one way to get 3 out of as a product of two things. That's a -8, which means we need one thing to be negative, one thing to be positive. There's a few ways to get 8, 8 and 1, 4 and 2, right? One of them has to be positive, one of them has to be negative. So at this point, I like to just put this one here like that, this one here to indicate the 3 and the 1. And then I just, think about, should I put an 8 here and a 1 here? Sorry, a -8 and a 1 there? Or should I put a 8 here and a -1 there? Or should I put a 4 here and a -2 there? Or a -4 and a 2 there? Those are all my possibilities, right? But again, these can be reasoned out, right? I need a -10 there, right, as my cross term. So I know that I probably want, so if I use 8, right, if I put an 8 here, 8 times 3 is 24. That's already way too big, right? I'm never going to get 10 out of the 1 and the x here. So I know the 8 and 1 is not going to work that way. 8 and 1 this way, well, 3, the cross term is going to be 3x, 8x. I'm never going to get -10 from 3 and 8, right? So certainly not. So that means 4 and 2. If I put the 4 here and a 2 here, I'm going to get a 6 and a 4, right? And that can combine to be 10, but in order to do that, I need a minus and a minus, right? Then I would get -6x -4, which would be -10. But I'm not supposed to have a minus and minus, because this guy is a -8. It's got to be a plus and a minus. So that means 4 and 2 are not going to work. Okay, so 2 and 4, right? And what are the signs? Well, I need a minus here and a plus here, so that when I multiply these two, I get -12, plus 2 gives me a minus 10. All right. Okay, and again, you can reason these out fairly quickly once you've done a lot of these. All right, one more. 3x plus 1. Oh, I revealed the answer. Sorry. 6x squared minus x minus 1. Right? So here, this guy has a couple possibilities, 6 and 1, 3 and 2. Whereas this guy here is just 1 and 1, with one of them a negative. So let's just write it like that. All right? So you just got to think about, well, can it be 6 and 1? Like, can I have 6x, x, like that? Right? Where these guys are 1s, you know, either plus or minus. Doesn't look like, because whatever happens, this 6x is going to multiply to a 1. So I'm going to get a 6x. And then the other one is going to be 1 and an x. And no matter what, there's no way the 6x and the 1x can combine to become a negative 1. Right? So there's no way it's not going to be 6 and 1. So that means it has to be 3 and 2. All right? Okay, if it's 3 and 2, how do I get, I know these two have to be 1, but they could be plus 1, minus 1, or minus 1 plus 1. Which one should it be? Well, 3x times 1 and 2x times 1, in order to get a negative 1 out of that, it has to be this and that, right? So the 3x times minus 1 gives me a minus 3x, and the 2x times 1 gives me a positive 2x. When you add those, you get the minus x. All right. So again, that's my thought process for this kind of factoring breakdown. All right. So that's kind of either a review or a quick introduction to factoring. And again, the homework problems will involve factoring, starting with a sine or cosine type of quadratic problem, convert it into this kind of problem, solve this, right? For example, here you would get x, if this was equal to 0, you would get x equals minus 1/3, x equals 1/2, and then, or sorry, it would have been y, right? And then you solve either sine x equals minus 1/3 or cosine x equals minus 1/3, sine x equals 1/2 or cosine x equals 1/2, and do each of those problems individually. All right, tedious, but at least the good news is every step is decently small and straightforward.